Okay, so in this video, we're going to do the other special trig limit. We're going to prove that limit as theta goes to 0 of 1 minus cosine theta divided by theta equals 0. Okay. So it could be 1 minus cosine theta, or you could have cosine theta and then minus 1 on top. It doesn't really matter. You could do the proof that way too. It's going to be the same thing either way. So let's go ahead and just start working with this. So it's really just going to be some algebraic manipulations. We don't have to do anything crazy or complicated like with the proof of the other special trig limit. But let's go ahead and start with this. So limit as theta goes to 0 of 1 minus cosine theta all divided by theta. Okay. So we can't do direct substitution. What happens? 1 minus cosine 0 divided by 0. Cosine of 0 is 1, so we have 1 minus 1, which is 0. So we end up with 0 divided by 0. And again, what that means is that you have to try something else. And in this case, what you would have to try is an algebraic manipulation. And it's not really obvious what to do, but a trick you can sometimes try with trig functions is multiplying by something like this. So here we have 1 minus cosine theta, so let's multiply the top and the bottom by 1 plus cosine theta. So you might recall having to do things like this in a trig class when you prove trig identities and things like that. It's really kind of the same idea. We're going to do something similar to working with trig identities to simplify this, or not really even simplify it, but just rewrite this in a form that's more useful to us. Okay. So really all we're doing is we're just multiplying by 1, okay, in a special way that's going to be useful to us. So 1 plus cosine theta divided by 1 plus cosine theta, that is 1, and we're just multiplying by 1 in a way that's useful to us so that we can rewrite this. So let's go ahead and do that. So this equals the limit as theta goes to 0 of, so what's happening on top? 1 minus cosine theta times 1 plus cosine theta. So we're going to have to FOIL, right? We're going to end up foiling here. And then on the bottom we have theta times 1 plus cosine theta. Okay, so let's just, let's not distribute the theta. We're going to leave it out separate like that. Let's not distribute it. And we'll just see what happens. So limit as theta goes to 0 of, all right, now if we FOIL, first gives us 1, outer is plus cosine theta, inner is minus cosine theta, so those are going to cancel. Plus cosine theta minus cosine theta, those cancel. So no harm in writing them though. So outer plus cosine theta, inner minus cosine theta, and then last is going to be minus cosine squared of theta, okay? Minus cosine squared of theta. And then on the bottom, we still have the same thing here. Theta times 1 plus cosine theta. Okay. So what does that simplify to? That's the limits as theta goes to 0 of, so plus cosine theta cancels with minus cosine theta, so we have 1 minus cosine squared of theta, all divided by theta times 1 plus cosine theta. Okay. And again, we are dealing with the limit, so make sure you keep writing this limit as theta goes to 0. If you forget to write that, it is technically incorrect because the limit as theta goes to 0 of this equals the limit as theta goes to 0 of this, etc., etc. So we have to keep writing this limit here. It is kind of a nitpicky detail, but it is important to be accurate with things like that. So what's happening now? So this is equal to the limit as theta goes to 0 of, so what is this? 1 minus cosine squared of theta. So if you think back to your trig identity days, is there a way we can write this in maybe a slightly more simple fashion? So remember cosine squared of theta plus sine squared of theta equals 1, right? So that's one of the most important identities in all of math pretty much, and certainly in all of trig. But we can rewrite this, so if we subtract cosine squared from both sides, then we have sine squared of theta equals 1 minus cosine squared of theta. Okay. So 1 minus cosine squared of theta is sine squared of theta. Okay, so 1 minus cosine squared of theta, that is sine squared of theta. And on the bottom we still have theta times 1 plus cosine theta. Okay? Alright, so now what we want to do is take this expression here, split it up. So let's get rid of this. And let's come up here. So we'll rewrite that just so we can see it. So limit as theta goes to 0 of... So sine squared of theta, let me rewrite that as sine of theta times sine of theta. And then we're still dividing by theta times 1 plus cosine theta. Okay? Okay, so now limit as theta goes to 0 of... so this whole expression in here, I'm going to take that and split it up into one fraction times another fraction. So this is going to be sine of theta over theta times sine of theta divided by 1 plus cosine of theta. Okay? So sine of theta times sine of theta on top, theta times 1 plus cosine theta on the bottom. So I'm just going to split that up into two fractions like this. Okay, so now the next step, and we do have to be careful in general about things like this. Now limit of this times this equals the limit of the first thing times the limit of the second thing. Now, so in general, we do have to be careful because this equality here, this is only true if this limit exists and this limit exists. Yeah, so if this limit exists and if this limit exists, then we can say this. So limit of a product is the product of the limits, okay, as long as both these limits exist here. So limit is theta equals 0 of sine of theta over theta. What's that? Well, that's the other special trig limit. Okay, that's the other one besides this one. That's the other one, and we've shown in a previous video that it's exactly equal to 1. Okay, so this this limit right here equals 1. Okay, so this whole limit equals 1. All right. Now, what about this limit here? So this we can actually just do direct substitution on this, right? There's no harm there, because we couldn't do that from the beginning because we get 0 over 0, but we can do that here. So that means that this limit exists and this limit both exist. So it's okay to have this equality sign here. So it's okay to have that. But what is this? So if we do direct substitution, we're going to have sine of 0 divided by 1 plus cosine of 0. Okay. Sine of 0 is 0. Cosine of 0 is 1. So we have 1 plus 1. So 1 plus 1 is 2. 0 divided by 2 is 0. So we have 1 times 0, which is just 0. And that's exactly what we wanted. Okay, because we started here, limit as theta goes to 0 of 1 minus cosine theta over theta. And the first thing we did was multiply by this big expression here in a way that's useful to us. Okay, and that's the special trig limit here. And limit as theta goes to 0 of 1 minus cosine theta over theta equals 0.